Hello, everybody. Welcome to another UCA Smart Grid session. I'm going to do a quick UCA need to know for our webinars. This webinar is being recorded. A link to access the recording will be sent within 48 hours to your email after this webinar ends. We'll also post this webinar to UCA's website and UCA's YouTube channel under our past meetings section. Please hold all of your questions until the Q&A session at the end. If you have a burning question, feel free to use the raise the hand feature at the top of your screen. Of course, you're welcome to also chat with participants in the chat box. UCA does follow antitrust laws, meaning anti-competitive business practices, especially when it comes to giving information. UCA hosted webinars are for educational purposes only and not an alternative to expert consultation for your specific needs. And then, of course, contact admin at UCA IEG.org for any additional information about UCA webinars. And with that, I will hand it off to Herb. Thanks for joining us today.
So we're going to have a little fun today. I know the original title was Why Use 61850, but when Ryan did the write-up on LinkedIn, I just kind of latched on to separating fact from fiction. So let's get started. The first thing to say is if you're expecting detailed 61850 information, this is not the presentation or the webinar for you. We just don't have enough time. At a minimum, that type of thing takes 4 to 8 hours. We are limited to 1 hour today. So I've been involved with 61850 and its precursor technology since 1982. So obviously I've got some strong opinions of why people should use 61850. So that wasn't kind of fair. So I asked Copilot, what are the reasons to use 61850 and what are the reasons, what are the cons to using 61850? So we're going to kind of use Copilot's results to kind of drive the webinar. And we're going to try and address all of the cons and talk about the pros as well. So here we go. Some of the stuff in the cons is no longer valid. It might have been valid 15 years ago, but 61850 has progressed. But large learning modules, getting them to unlearn information is just horrific. So you got to have critical thinking when you look at these things. So the first thing is a lot of people think 61850 is just a protocol. It's much more than that. And you can see the major headings up at the top. We cover everything from introduction to requirements, to object definitions, to functional definitions, to the actual protocols. How do you do engineering and configuration and testing? And unfortunately, some people say 61850 isn't a protocol because of all of this work, but there is a very substantial protocol component. The first thing to do is to take a look at why 61850 was developed in the first place. And 61850 was developed to lower the integration and system maintenance lifecycle cost of a system installation by hopefully 80%. So there's a very strong business reason to use 61850 to decrease your commissioning, maintenance, and lifecycle cost. There's an IEEE paper that discusses the differences between a 61850 and BNP substation integration one can happen in a couple of hours, the other took 3 days. So there are substantial savings. And as I said, 61850 targets to decreasing the life cycle and installation and maintenance costs. So how do we target that? In the US, if you ask the Europeans our engineering process, they say we're cowboys. 61850 tries to apply a structured approach to the chaos. So let's talk about some of the underlying basis of 61850. A lot of the protocols that people use today use numbers and not names. So when's the last time you actually remembered a phone number? You remember the name of the person so you can look it up in your phone, and if their phone number changes, AKA the number changes for an index, you look it up by name and you get the new number. So names are used as an alias in 61850 that maps to the back end. And therefore, if the actual memory location or index that the name is bound to changes, you can just change the binding and your integration stays the same. The problem with names is you put 3 people in a room and they come up with 10 different names, and utilities all have their own naming conventions. And for those of you who haven't seen it, I've seen it, and it makes it difficult for one utility to communicate with another utility. So 61850 actually defines named semantics. And here's an example. So for a 3-phase Y transformer, phase A is named phase A, phase B is named phase B, there's neutral, there's phase C, and for a delta is kind of similar. So at this point, from a measurement perspective in 61850, if you want to read phase A of a Y transformer, some portion of that name is going to say phase A. We also support single phase measurements versus metering, control functions, all of that stuff. For better or for worse, 61850 takes the personal set or corporate opinions of names out of the equation. The semantics, and you can see up at the top, Copilot says standard allows flexibility, vendors interpret optional features differently. Not a true statement any longer. It's true that 61850 specifies mandatory and optional semantics. The optional semantics in the standard are very well defined. It's just a question if a vendor implements that semantic. And if the vendor wants to do an extension, 61850-7-1 specifies a standardized mechanism for extending it. It's through what's called a namespace. And this allows flexibility and innovation. It allows for an evaluation of that enhancement to be included in a future standard. And names are just much better than assigning an index. Now, for these extensions, they are not interoperable. So we standardize not only the semantics, but standardize the functions. So if you take a look at your cell phone, you have a group of applications that you have decided you need because you want to do certain functions. In 61850, the concept of logical nodes is a function, and you choose the function that you need to perform a given substation or power system function. So this diagram, this picture just kind of shows that logical nodes, think of them as, when you instantiate them, as being the equivalent of putting an app on your phone. There are structures of 61850 servers. There's a server, which is an IED. There's a logical device, which is a grouping of functions. There are your logical nodes, which actually represent functions. And let's just take a second, because this layer has standardized names for functions. So like PTOC is time over current protection. CSWI is switch controller. MMXU is a measurement unit. And GGIO I hate because it's generic IO and it's not much better than indexes. If you do a deep dive into the logical node naming conventions, the first character gives you a clue of what the intent of the function is. So P is protection, C is control, M is metering and measurements. Each logical node consists of data objects, which consist of data attributes. So if you want to read a amp reading in 61850, it's pretty much always going to be A. And all readings and status data objects or data attributes typically come with a timestamp inequality. A IED may be physical or virtual, for those of you who are interested in virtual protection. As I said, a logical device is a grouping of related features and functions. Here's your function level data objects, and we've already covered that. Okay, so let's talk about the standardized configuration processes. You have device vendor information, you have a system tool, you configure through your system tool your communication flow, virtual inputs and outputs. You provide that output to a vendor-specific device configuration tool. You do some cleanups potentially, and then you put them into your device. Now, what is in yellow here is what everybody does today, because you're configuring devices through pretty much a device specific configuration tool. What 61850 brings along is a system tool and a standardized way of representing the vendor information, the output of the system tool, which is used as the input to the vendor device configuration tool. And then the vendor device configuration tool actually configures the devices. So this is a top-down approach, or the start of it, and let's talk a little bit more about that. So when you look down the road, you want to specify for, transfer trip or bus differential applications, specific things that you want. So 61850 now has something called an application-specific description file, which allows you to create a template for what you need for a particular building block of a system. That ASD can feed into a system-specific description or system specification function that you can then send out to a vendor as an IED specification, and then the vendor can respond on how they can meet that specification. Devices are required to have what's called an IED capability description file, which then gives their capabilities to the system configuration file, system configurator, sorry, which outputs a system configuration description file, which goes to the IED configuration function and configures the device. And if there are changes made, that information can be fed back to the system configuration tool. Now, Copilot says archiving of SCL is a problem, but you're already doing it, right? You have many documents that specify your requirements, but they typically aren't machine processable. You have manuals that state what your vendor capability is. And the system configuration tool in the SCD is an as-is built. So you're already archiving many documents and don't really have an as-built document. And the SCD is the as-built. So I take exception to Copilot saying archiving of SCL is a problem. I think it's a benefit. So the as-built SCT contains all types of goodies. It contains all your communication addresses, all your data and type information. It can provide all your subscriptions and signal routing. Some SCTs can actually generate wiring diagrams. It allows you to create single line diagrams and bind the semantics to topological points in the single line diagram. You can specify network connectivity for configuring switches. And at the interops, we are actually testing, can we configure our network of switches based off of a SCD? Some EMS SCADA systems or ADMS systems can actually import the SCD and configure itself and potentially even generate the single line diagrams off of it. So there are lots of benefits to using SCL today and in the future. So SCL management and file control, that's one of the other issues Copilot had. But top down versus bottom up, it drives the evaluation of where approved IEDs don't match your design objectives. And if you don't do this analysis in a project, and I've seen it, you may end up saying, oh, my device claims it does 61850, and you decide to adopt it for a project. And lo and behold, it doesn't do the function that you want it to do, and you have to cobble together a Rube Goldberg to make the system work. Top down versus bottom up definitely causes procedural changes that have to be addressed, and it's a cultural change. I personally believe the potential business cost savings are worth it after the first training project. The first project is always difficult. Detroit Edison estimated that it can save 100 to 200K per substation using SCL instead of spreadsheets. And it eases governance issues. So file management and governance, most current systems use spreadsheets, requirement documents, network diagrams, topological diagrams. SCL can handle all of the above, as the SCD is the as-built. Other SCL benefits, it is possible to convey the communication network topology and configuration settings. Since most of the settings and measurements and control are all in SCL, it's possible to automate testing. And eventually, as more SCADA, EMS, DMS, ADMS vendors support importing SCL into their systems, that represents a potential huge cost savings. So the ASD allows SCL to take into account vendor flexibility. So again, Copilot is a little wrong. Vendor-specific IED configuration tools don't represent an issue because we're all already using vendor-specific tools for configuration. There needs to be a point of demarcation from converting standardized files to proprietary files, and that's the purpose of an ICT. So let's talk about the transition from analog to digital. And this is sample values. So if you think about how the analog world does CTs and PTs, the analog signal is calibrated and goes into a digital signal processor that outputs, volts, harmonics, etc., and feeds into the process. So for every connection to an IED from a CT or a PT or VT, you have a cable. As opposed to doing merging units where basically the DSP is put in close proximity to the CT or VT, and the DSP actually sends digital communications to the IED. So and Goose actually allows higher speed automation than hardwired logic because of debounce time and output pickup time. Anyway, Goose is guaranteed delivery, and I'm sorry for email popping up down there. Secure routable Goose can also be used to replace current teleprotection technologies. Goose is guaranteed delivery because it retransmits the current state. And the benefits, putting it to use. Well, we talked about reduced wiring. Copilot got that right. This is an example of how much wiring was actually able to be pulled out of a substation due to converting to 61850. It also can provide more efficient diagnostics. So here's a Wireshark capture of a Goose message on the network. no real semantics except in relation to the header of the goose. But if you have a tool that can read the SCL file, now you know the names of the actual information that's going across your network. You don't have to look at it on a piece of paper. And even though Wireshark has this potential, there are other commercial tools that can do this as well. And there are others. Okay. These are just two examples of commercial tools that can expose the names of the data that's actually going across your network. Again, it's a major benefit for maintenance and diagnostics. So let's talk about one of the concerns that a lot of people talk about, which is how do I isolate and test a digital 61850 system? So let's talk about the testing onion first. UCA has a huge role in doing conformance and interoperability testing. Conformance testing is, in my mind, an extension of the vendor quality assurance program, and system testing and unit functional testing is really a customer acceptance issue. So let's talk about conformance versus interoperability. They are totally different. You can be conformant and not interoperable. You can be interoperable but not conformant. So it's important to do conformance testing and interoperability testing. So on the left-hand side here, you can see some of the 1,600 certificates that have been posted for 61850 conformant products or compliant products. There is a very extensive process for accrediting testing labs and verifying that the certificates they provide to be posted are actually correct. So if you're walking down a 61850 system, this is a good, the redmine.ucaiug.org is a resource to go to see what your particular device has been tested to be in compliance for. Now, UCA interoperability is a multi-vendor testing function. It occurs every 2 years. The next one is in 2026 in Utrecht, Netherlands. And you can, this was the last one from Birmingham, Alabama. We had about 120 people participating. It is a place for geeks and engineers, not marketing types. Here's our wonderful network layout. We actually laid out a control center and basically 3 substations in the course of 3 days, 3 or 4 days. We are doing extensive testing on PTP time synchronization. So if you are interested in coming, you can still register for the interop at the link shown below. So how do we isolate systems for testing? Today, you have a test block where you remove the jumpers, you take a test set and you feed the inputs to the device. None of the other devices see what is going on with device 1 because the test jumpers have been removed. But the HMI and SCADA doesn't know that the test set is hooked up. So an operator may make decisions based upon injected test data as opposed to real operational data. So in 61850, pulling the test jumpers is the equivalent of putting a device into blocked operation. And we'll get into what that means in a minute. But when you go into test mode or test blocked, the quality associated with the data shows that you are in test mode and if you are in blocked mode. And if you are sending quality data back to your HMI or SCADA system, it knows that that the source is not reporting real operational data and can let the operator know. There is some best practices, at least I consider them best practices, on how to wind and unwind testing and blocking, and this slide actually shows that. There is a mechanism in 61850 to say, I want to be allowed to do accept simulated data, in other words, from the test set. So you put the device into test blocked. Simulation, accepting of simulated data is still false. Then you take simulated to true, and now you start receiving simulated data, testing your device. But since the outputs are blocked, you've basically removed those jumpers. To unwind it, you take simulated to false and then put it back into normal operation. And this is one of the things that is conformance tested as part of the control model. So you can test a single device through this mechanism. You can test it as part of a test campaign with other devices. So if a device is not in test mode, it won't accept data that is marked as test. So let's talk about the penetration and SCADA use. Why isn't the use of 61850 more prevalent? There are some additional requirements for NERC SIP if you use external routability. I personally believe external routability is coming, especially with virtual protection. And if you want to not have to roll a truck for maintenance and upgrades, you're going to need external routability anyway. SCADA ADMS systems have been slow to support 61850, at least in America, because we're DNP centric or Modbus centric. There are a couple of systems that do support it. Due to business evaluation, you may want to start specifying 61850 capability in these systems as part of your RFP or RFI. It's going to take a while, but I suspect with the business savings that can come along, you may want to start evaluating that. So, what about cybersecurity? This slide is just so you know it's being taken very seriously. Working Group 15 of TC57 is the working group that's responsible for TC57 cybersecurity protocol, standards if the core standards committees don't want to address cybersecurity. And guess what? Most of the core standards defer to Working Group 15 and then bring references back to the core standards by referencing the appropriate 62351 series standards. So if you ask, is there a 61850 standard for cybersecurity? No. The answer is specifically that there are 62351 standards for 61850 security, and 61850 references those. Okay. The one thing I will say is we have a lot of people that talk about 61850 90-5. That has been deprecated and now has become routable goose, that, and the technology that's was in 90-5 is being removed and is not interoperable with the current secure technologies that are in 61850.8.1 edition 2.1 or 62351-9. So if you want routable goose, don't mention 90-5 in your RFPs. So 61850 has MMS, client server, has had cybersecurity capability since 2001. Goose has had cybersecurity since 2007. We've been making continuous improvements. Many implementations have implemented client server security, but utilities have not requested it. So that's another thing that's going to need to be addressed in your RFPs and RFIs. This is an eye chart. I'm not going to go over it, about how all the various NERC-CIP regulations can be met or assisted by adopting 61850 or related standards. Now, Copilot did get it correct that there is a learning curve to 61850. The concepts behind it are not that difficult, but they need to be embraced. Corporate processes will need to change, but as digital substations provide business benefits, it's coming. It's just like AI. So 61850 is going to take most utilities out of their comfort zone and into a growth zone. Now, how long that takes is up to each utility or customer. Other benefits that are coming, we're working on a way to standardize how you update and maintain firmware, configuration, all of that stuff. So theoretically, you won't have to roll a truck to do firmware updates in the future. And it's addressing the cybersecurity aspects for that. There's role-based access control that's been validated, and we're getting close to publishing the international publicly available standard on that. So you can have different roles for different users that gives rights to access different data objects and services. If you take a look and read about the VPAC Alliance, 61850 is the core technology for virtualized protection. It's being used in substations for data centers, and it integrates with 62351 security. The one thing I didn't put up here is because of the semantics, the standardized semantics, it's malleable to AI analysis. And we're pretty much all headed that way for maintenance and condition-based maintenance, and even for cybersecurity. So at that point, I've finished the presentation, and it's time for questions, if there are any.
Yes, if anybody has questions, you have a Q&A button at the top of your screen. If that's not available, feel free to use the chat, the general chat box that is, to submit some questions now, please.
I don't see any Q&A or chats.
You're right, I don't see any questions coming in. Well, if that's the case, we don't have questions. That'll be a first, but we appreciate everyone coming. Oh, we got a hand up from Adam Peretti there.
Hey, Adam.
Here we go, Herb. I got a few.
Okay.
So Adam's first
Adam
question
raised
here.
his hand or not?
Yeah, he's got a question here in the Q&A. He can't use his mic. So here's the first question, Herb. You mentioned DTE being a success story. Are there other utilities in the US that are 61850 standardized?
AEP has been using the precursor of 61850 forever in its substation. The precursor was called UCA. They are actively walking down the smart digital substation path with 61850 today. There are other utilities such as SCE that are using it for its centralized remedial action scheme. I think PG&E uses it for protection within its substations, but brings it back to their SCADA EMS, through DMP. Let's see, who else do I know? National Grid is committed to it and using it. I do not know how many substations they have of it. Let's see. Hydro-Quebec in Canada is an extensive user. Let's see, who else do I know of? There are others. It is encroaching into the United States, and Southern companies using it for virtual protection as well.
Thank you, Herb. The next question here is, have you come across hallucinated AI? And I would guess that specifically speaking in relation to 61850.
No, I have not come across hallucinated, but if you can explain what you mean, I know AI gets a lot of stuff wrong all the time. Is that if that's what you mean by hallucinated, I've experienced that. If it's a particular brand of AI, no, I don't use it.
All right, next question. For the adaptation of configuring the network with SCL, what is the progress with SCTs?
So not to go into specifics, but the mechanism to configure that has always been in SCL. I'll say this, system configuration language. If you look at a major substation SDN vendor, they use the SCD to configure their SDN network. At the past 2 interrupts, we've had switch vendors also picking up on that, along with the SCT vendors, and we're going to retest it in Utrecht as well. So it's maturing. Hope that helps.
It does. And a little more context to the hallucinated AI question. The commenter says AI, as in telling you about LNs that do not exist at all. Does that help you to expand that answer, Herb?
Well, as I said, they've learned it from somewhere, and getting it out of the learning module is almost impossible. But there are, let me try and find this.
One moment, folks, as Herb tries to find a piece of material that can give a
Yeah,
shine a little more light on the answer.
Herb,
Are you comfortable with answering a couple other questions while you're looking for that
sure,
item?
sure. I'm almost there.
Okay.
Go ahead.
There is one question here. I'm not sure if we can answer on this call, but it says, may you mention some commercial SCL tools?
I will happily talk about the 3 or 4 SCL tools that have consistently come to the interrupts. One is from Helix, the other ASC Calcitech, Schneider Corporation. Those are the 3 that have really stood up and continue to improve in the areas. And those are the ones that are not really vendor specific either. So I'm going to reshare if I can. This takes a while. So I'm also going to try and chat something. Did you guys get the chat?
Yes, Herb, I see that it came through.
Especially the hallucinated AI person. I don't think you can see this yet.
Here we go. I got you. There you go. Now your screen is sharing.
So this is a little known site at IEC that allows you to download what are definition files in XML that allow you to know what the standard data types are, standard services are, and standard logical nodes. So if I search this for 7-4, so here's all the logical node information that basically is from 7-4. 7-420 is DERs. Would you guys like to take a look at what's in one of these?
Sure. Give us a quick look, Herb.
Yeah, I can download it. And the purpose of these files is to, there may be a better way to get at this. Yeah, too late.
And with 8 minutes remaining, Herb, I do have 2.5 questions remaining for you.
Okay, let's just. Always a problem. Okay. It did not import well. Okay. Let's go the other way. So it talks about the abbreviations. Here are your enumerations. And here's your logical node classes. So these files are not really give you the full definition. I hope that helps, but.
It does. It's a nice little sneak peek. Thank you, Herb.
All right. What are the other questions?
All right. We have another question from Adam. So looking at the other presentation materials, it sounds like MMS has a challenging CIP requirement. Are most utilities sticking to just Goose for substation digitization? And does MMS have more adoption with microgrids and DERs?
So I don't think MMS, except for the external routability, has any additional issues than any other protocol that's in use for sorry about that, for ingress and egress to a substation. Within a substation, it has no additional encumbrances than any other protocol. I hope that helps. And it's got a very strong cybersecurity capability. The issue is the SCADA EMS systems don't support it. I hope that helps. That's the thing that's been holding it back from ingress and egress to substations.
Okay. Thank you, Herb. And if there is an answer that doesn't go all the way, feel free to reach out to Herb at Herb at ucaiug.org. And then last question for you today, Herb. What interoperability tests do you recommend performing to validate parameters such as SCND, TMMS? I'm not sure how you'd pronounce that, and then clip factor and max DI.
You know, you're going to have to determine that yourself, because those are pretty much, you know, I hate to say it, power system specific, I believe. But reserve TMS with the conformance testing of edition 2.1 is mandatory. So if you've got a device and it's got a conformance certificate for 2.1, let's go here real quick. Am I still sharing? Yes. Oh, let's take one here. So can you see this here? Optional reservation test?
Yes, we can.
Okay. That's saying that for edition 2.1, that test has been done. Okay. And if you want to look at the certificate, you can click on it and you can see actually in the certificate which test cases were actually performed. So this certificate did direct before operate, select before operate, which would have been the reserved TMS, enhance direct and enhance select before operate control. So this guy had it tested.
This is great. Thank you, Herb. That helps us to better understand some of the items in Redmine as well as the certificates. Thank you.
No problem. Anything
All right.
else?
No, sir. I believe that's everything. I want to, on behalf of UCA and the attendees, we thank you for your time. This is very informative, and we always love to hear you talk. So thank you, Herb, and we hope you have a great day.
And thank you all for attending.
All right, now, have a good day, everybody. Thank you.